Now let's turn our attention to another very important sensory element that we find and associated with our musculoskeletal units, and this is called the Golgi tendon organ. The Golgi tendon organ and the spinal reflex derived from its sensory signals provides us with a system that monitors the force that's generated by a contracting muscle. So the stimulus then that activates the Golgi tendon organ is tension. That is the force that's generated during the active contraction of the extrafusal muscle fibers. The Golgi tendon organ is relatively insensitive to the stretch that is applied to a skeletal muscle, and that's because most of the stretch is absorbed by the muscle fibers themselves. The Golgi tendon organ is a structure that's found not in the muscle fiber per se, but in the tendon that attaches the muscle fiber to the skeleton. So what we find in this region of this musculoskeletal attachment is a set of nerve endings that come from a sensory axon called the group 1B afferent neuron. And these endings are woven into the fabric of collagen fibrils that we find here in this region of the tendinous attachment to a muscle. And this anatomic relation between the nerve elements and the collagen fibrils make this structure activated as tension is created. So as these muscle fibers contract, they generate a force that tugs on this region of the Golgi tendon organ, and that causes a deformation of these terminals that are woven in among these collagen fibrils. And that deformation opens stretch-sensitive ion channels that result in the influx of cations and the generation of potentials that, if greater than threshold, can lead to an action potential that then propagates into the central nervous system. Now let's look into the spinal cord and see the circuitry that we find that receives this incoming sensory information. Now, we can think of this system in operation as a form of negative feedback. The Golgi tendon organ is going to be activated by the tension that's generated as the muscle contracts, and the physiological effect of that sensory signal is going to be to diminish the output of the alpha motor neurons that supply the contracting muscle, and thereby reduce the amount of tension that's generated. So this is kind of a negative feedback system. Now, the physiological effect of activating this Golgi tendon organ is that the output to the muscle that's generating force is going to be diminished. And this implies that there must be some kind of an inhibitory interneuron interposed between the sensory signal and the alpha motor neuron. And indeed there is. This is called the 1B inhibitory interneuron. It is a dedicated type of inhibitory interneuron that is postsynaptic to this 1B afferent. And it makes presynaptic terminals on the alpha motor neuron that's responsible for the force that's being generated by that contracting muscle. So as this 1B afferent is activating this 1B inhibitory interneuron, there is going to be synaptic inhibition and a reduction in the output of that alpha motor neuron. And this is going to diminish the force or the tension being generated by this contracting muscle. Now, as usual, we have a pattern of reciprocal innervation, such that as we reduce the activity of the flexor muscle, we're going to actually increase the activity of the extensor muscle. And this will help stabilize the movement around this particular joint. And so this happens via disynaptic excitation of the alpha motor neuron that innervates the extensor muscle. So in both sets of alpha motor neurons, we have an interneuron interposed between the incoming 1B sensory signal and the alpha motor neurons. However, in one case, we have a sign-inverting interneuron, that is, an inhibitory interneuron that takes the excitation coming through the sensory arc and turns it into an inhibitory signal that suppresses the motor output. On the other side, on the extensor side, we have an excitatory interneuron that conserves the sign of the sensory signal. That is, excitations coming in from the Golgi tendon organ, and that serves to increase the output of the extensor motor neuron. Well, what good is this system of Golgi tendon organs? Well, we think it's very useful for monitoring the force that's generated by an actively contracting muscle. The activity of this 1B afferent is modulated up or down throughout the course of an active muscle contraction. And we can imagine that this might be very helpful in combating fatigue that might be setting in. We can imagine that as a muscle is fatiguing, it's generating slightly less force. That's going to be reducing the sensory signal into the spinal cord circuitry, and that would diminish the inhibition then in the 1B inhibitory interneuron. And with less inhibition, this might be a way of providing for a reflexive increase in the activity that would help combat that fatigue that's setting in on the contracting muscle. We think that this might also be important if a muscle fiber should be directed by the central nervous system to generate contractile forces that are potentially damaging. So this is a form of negative feedback that would potentially help protect the muscle and potentially its tendinous attachment as well against excessive forces that we might otherwise attempt to generate. Now, like all of our systems of segmental reflexes, the Golgi tendon organ reflex arc is subject to modulation via descending pathways. These descending pathways certainly facilitate various dynamics of human movement that we may choose to participate in. One example might be resistance weight training that some of you may be engaged in, where you might actually want to generate very large forces of muscle contraction, perhaps forces that put you at some risk. And if your Golgi tendon organs are trying to minimize that risk, you can imagine that these descending inputs might actually facilitate the achievement of that very large force of muscle contraction. Certainly any competitive weightlifter would have to have a very well exercised set of descending projections that can interrupt the activity of this Golgi tendon reflex. Otherwise, it would not be possible to generate the forces necessary to be competitive.